In this video, we are going to talk about solving logarithmic equations. So we're going to have two types of logarithmic equations we're going to focus on today. The first type is if we have logarithms on both sides that have the same base. Then what we're going to do is set those arguments equal to each other and solve for x. Then we always want to check our solutions because some solutions could be extraneous. The second situation is when we have a logarithm just on one side of the equation, and so we're going to isolate that logarithm term, rewrite it as an exponential, solve for x, and then check those solutions. So we're going to go over these two types of solving today. So in this first one, we have the type where I have logs on both sides, and notice they're both log base 4. So since my bases are the same, I can set my arguments or my insides equal to each other. So I'm going to set 2x plus 8 equal to 6x minus 12. I'm going to move my variable to one side. Then get the variable alone. So I'm going to get 20 equals 4x. And so I'm going to get that x is 5. Now to check these, I'm going to plug them back into that original equation. So I'm going to say, okay, log base 4 of 2 times 5 plus 8 should be equal to log base 4 of 6 times 5 minus 12. So on this left side, I'm going to have log base 4 of 18 because I'm going to have 10 plus 8. And I'm also going to have log base 4, well, I have 30 minus 12, which is also 18. So since log base 4 of 18 is equivalent to log base 4 of 18, I know that 5 is my solution. In this next example, again, we have our bases the same. So I'm going to set the insides equal to each other. So I'm going to have x plus 2 equals 2x minus 5. I'm going to move the variable first, move the constant, and I'll get that x is equal to 7. Now again, I want to check it similarly to above. So I'm going to put 7 in for x. Seven plus 2 is 9. 14 minus 5 is also 9. So 7 is the solution to number 1. In number 2, we're going to start this problem the same way. I have log base 6 and log base 6, so I'm going to set my arguments or my insides equal to each other. Now this time's a little bit different because I have an x squared, meaning I have a quadratic equation. And when we have a quadratic equation, we want to set our equation equal to 0. So since the x squared is on the left, I'm going to move everything over to the left. And so I'm going to get x squared plus 6x. Well, negative 3 plus 3 is 0. And so I'm going to have negative x, or sorry, I'm going to have x squared plus 6x equals 0. Now I'm going to factor this by taking out the GCF. So if I look at these terms, I have x squared and I have 6x. So the GCF between those two is going to be x. So I'm going to undistribute or factor out that x. And when I do, I'm going to have x plus 6 left in my parentheses. Still equal to 0. Now to solve, I'm going to set each of my factors equal to 0. So I'm going to set x equal to 0. And I'm going to set x plus 6 equal to 0. Now, x equals 0 already is solved. I'm going to finish solving this one by subtracting 6. And so I'm going to get solutions of 0 and negative 6. Now, I need to make sure I check these solutions. So I'm going to plug in 0 first. So I have log base 6 of 0 squared minus 3. And that should equal log base 6 of negative 6 times 0 minus 3. So I'm going to end up having negative 3 and negative 3. So this appears as if it would work, but a log can never have a negative number on the inside. You cannot take the log of a negative number. And so since the inside here became negative, that means 0 is actually not a solution in this situation because you cannot take the log of a negative number. So let's see what happens when I put negative 6 in. So log base 6 of negative 6 squared minus 3 needs to be equivalent to log base 6 of negative 6 times negative 6 minus 3. Now I'm going to have negative 6 squared, which is 36, minus 3 is 33. On the right side, I'm going to have negative 6 times negative 6, which is positive 36, minus 3, which is 33. Now, negative 6 actually does work because it gives me a positive value in my parentheses, and so I can take the log of a positive number. So negative 6 is the only solution to this equation. All right, now we're going to take a look at our second type of log, and this one we have a log on one side. And so our first step of this is to isolate the log. So I want to get this log of 2 of 2x, log base 2 of 2x alone. So to do that, the first thing I'm going to do is minus this 1 to the other side. And then remember, this 2 is technically multiplied by that log, so I'm going to divide by 2. Now, I'm going to do the opposite of what we did when we were solving exponential equations. We went from exponentials to logs. Now I'm going to go from logs to exponents. So I'm going to take the base, which is 2, raise it to a power of 6, and then set it equal to the argument, which is 2x. And now I'm going to solve this. So first I need to do the exponent, so 2 to the 6th power. If you type that in your calculator, you'll get 64. And then to finish solving for x, I'm going to divide. So I'm going to get that x is equal to 32. Now to check this, I'm going to do 2 times the log base 2 of 2 times 32. I apologize. It's 2 times x here. So 2 times 32 plus 1, and that should equal 13. So 2 times the log base 2 of 64 plus 1 should equal 13. Well, log base 2 of 64 is 6, so 2 times 6 plus 1 would equal 13. All right, in this one, my log is already alone, so I'm going to go straight into exponential form. So I have a base of 7 raised to the 2nd power. So a base of 7 raised to the 2nd power is going to be equal to 3x minus 2. Now, similarly, I'm going to change this to be a 49 first. Then I'm going to use the rest of my solving skills to finish solving. And so I'm going to get that x is 17. So now to check this, I'm going to have log base 7 of 3 times 17 minus 2, and that should equal 2. Too many parentheses. 3 times 17 minus 2. So I end up with log base 7 of, well, this is 51 minus 2, so log base 7 of 49. And should it equal 2? So the way to check this is like, well, is 7 to the 2nd power 49? Yeah, that's true. So log base 7 of 49 does equal 2. 4 is really similar, so I'm going to skip that one for now and go on to number 5. So number 5, I have this 9 in front. So again, I want to get the log alone, so I'm going to divide by 9 first. I'm going to get log base 2 of x is equal to, well, 15 over 9 will reduce to 5 over 3. So we're going to reduce that fraction to 5 over 3, and we want to write it as a fraction because it's not a terminating decimal. So I'm going to do 2 to the 5/3 power is equal to x, and I can just do that in my calculator. So 2 to the, but make sure when you're entering it in your calculator and you're using the caret, you put that fraction in parentheses. So 2 to the 5/3 power, and I'm going to get that x is 3.17. Now this one's a little bit trickier to check, but if you have a TI calculator, we could just type it in as 9 times log base 2 of 3.17, and it should equal about 15, which it does. All right, let's look at this last one, number 6. So again, I want to get this log alone, so the first thing I'm going to do is divide by 10, and so I'm going to have log of x minus 1 equals 2. Now this one appears weird because I don't see a base number right here. So remember, when there's not a base, our common log is base 10. So basically, if I just see log, I know that it actually means that it's base 10. So now I can take my base, which is 10, to the exponent of 2. and set it equal to x minus 1. So again, that first step is to change 10 squared to be 100. And then I'll get a final answer of 101. Now to check this, I'm going to have 10 times the log of 101 minus 1. And so I'm going to have 10 times the log of 100. Well, again, the log of 100 is log base 10 of 100. So basically 10 to what power is 100? So log base 10 of 100 is 2. And 10 times 2 would give me 20. So this is the correct solution.